Okay, this is the first video for the 9.6 handout that you're supposed to be viewing for your homework. And in 9.6 we learn a couple new theorems and actually two formulas that you're going to see. We'll start with the formulas and then I'll prove several of them. Okay, if you look in the upper left here, we've got a theorem about angles formed between two chords. You see I've created two chords here, and in doing so I've created two arcs. I'll label arc A in turquoise and arc B in yellow. And then you see that I've labeled one of the angles created by the intersection of the two chords as x. It turns out that x is equal to A plus B divided by 2, which is basically the average of the two arcs that are intercepted by the chords. We'll come down a little bit and prove that. Okay. Got a similar diagram here, two chords intersecting in a circle. I've highlighted arc AC created on the left and arc BD created on the right. And I'm supposed to basically prove that formula that I just showed you, the A plus B over 2. Although in this diagram we're calling A arc AC and B arc BD. So no surprise here, I'm going to add an auxiliary line into my diagram. And actually angle 1 was supposed to be labeled on this diagram. With my auxiliary line, you might notice that I've created a triangle. And I'm going to go ahead and label a couple more angles in that triangle, angle 2 and angle 3. This particular idea has come up a little bit in the past few days, that the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. The idea that the exterior angle of a triangle is equal to the sum of the two remote interior angles in the triangle. Just to be clear here, I'll highlight the triangle that we're talking about in green. Okay. Angle 1 is built off of the green triangle, an exterior angle, and it's equal to the sum of angle 2 plus angle 3. That gets us started. Alright, next, let's take a closer look at angle 2. Okay. Measure of angle 1 is in what I need to prove, so that doesn't need to go, but angle 2 and angle 3 need to be replaced with something in order for me to arrive at this result. So what can I write for angle 2? Well, if you look, angle 2 is actually an inscribed angle. Its vertex lies on the circle, and its endpoints are at A and C. And we learned today that the measure of an inscribed angle is equal to half the intercepted arc. So I can say that the measure of angle 2 is equal to 1/2 the measure of arc AC. And if you look at angle 3, which also needs to be replaced, it intercepts arc BD. So measure of angle 3 equals 1/2 the measure of arc BD. Okay. Inscribed angles equal 1/2 the intercepted arc. New theorem from today. So let's go ahead and do that substitution that I was referring to. We want angle 1 in our proof. So let's replace angle 2 with this. 1/2 the measurement of arc AC plus 1/2 the measurement of arc BD for angle 3. And after that, which is just substitution, it's really just rewriting the statement. I factored out the common 1/2. Okay? So you can actually put the 2 on the bottom of a fraction if you prefer. And then it kind of looks like that formula I wrote up top, a plus b over 2. All right, I've got 3 more boxes, and you may be thinking, oh no, 3 more formulas, but actually the rest of the boxes all follow the same formula. Instead of x equaling a plus b over 2, it's going to be a minus b over 2. X equals a minus b over 2. Okay, so let's check out what that means. In the upper right box, what's that going to mean is if you have 2 secants going through a circle, you can take the bigger arc that's been intercepted, subtract the smaller arc that's been intercepted, and divide by 2 to obtain the measurement of x, the angle formed by the 2 secants. Turns out that formula works not just for 2 secants, but for 2 tangents. The larger arc, A, minus the bigger arc, the smaller arc, B, if you divide that by 2, you get the angle formed by the 2 tangents. And then finally, if you mix it so you've got a secant and a tangent, still works. Larger arc, subtract the smaller arc, divide by 2, and you get the angle formed by the secant and the tangent. I'm just going to go ahead and prove one of these. Come down here, I'm going to prove the case with 2 secants. So, given 2 secants, prove that angle 1, I've called it here, it's x above, but here it's 1. Prove that angle 1 can be obtained by taking the larger arc measurement, subtracting the smaller arc measurement, and dividing by 2. Okay. So, based on what you saw in the previous proof, I bet you're not surprised that I'm going to go ahead, put an auxiliary line in, and create a triangle. I am going to need to name a couple more angles, angle 2 and angle 3. Okay. And just like we did last time, let's start with a statement about the measurement of angle 1. Except this time, angle 1 is not the exterior angle. It's actually angle 3. So before I write something about measurement of angle 1, let's write measurement of angle 3, which is the exterior angle. And I'll say that that's equal to the sum of angle 1 plus angle 2. Let me highlight the triangle that we're talking about so it's clear. Okay. Hopefully you see that angle 3 is an exterior angle. Angle 1 and angle 2 are the remote interior. And we know that exterior angle of triangle is equal to the sum of 2 remote interior angles. Now I wanted measurement of angle 1 to be on the left side to get to the thing that I need to prove. So all I'm going to do is just rearrange this. If I want to isolate the measurement of angle 1, then I need to subtract the measurement of angle 2 from the measurement of angle 3. So that's just the subtraction property of equality. Okay. All right, again, angle 3 and angle 2 have to go. So what can we write about the measurement of angle 3? Well, similar to the last proof, it's an inscribed angle. The intercepted arc is AC, and we know inscribed angles are half the measurement of the intercepted arc. And take a look at what angle 2 is intercepting. It's also an inscribed angle, and it's intercepting arc BD. Okay. So inscribed angles equal 1/2 intercepted arc. And let's do some substitution just like we did in the last one. 1/2 the measurement of arc AC for angle 3 and 1/2 the measurement of arc BD for angle 2. And after that, we can just write equivalent statements. That was a substitution. Pull out the 1/2. And it begins to look like the formula if you put the 2 on the bottom and the arc measurements on top. It starts to look like A minus B over 2, like you see up here. At this point, you should go ahead and try the problems on the first page of the 9.6 notes, and then look at the next video to see if you got your answers correct.